I was one, that was primary 6. Right now here, we're still going on with our ordinary differential equations. Well, in our ordinary differential equations, we are at, for an example, so we have already 2 methods to find the particular solution. The first method, just by coefficient comparison. The second method is by the operators method. So the example I'm going to give here will be this 5th derivative of y, then you minus. So at this point you minus 20, then 4th derivative of y. Then you add 160, 3rd derivative of y. Then you subtract 640, 2nd derivative of y. Then you add 1280, 1st derivative of y. After that, you subtract 1024. Then here is just y. Then after that, this part is equal to x e to the power of 4x. So it is for this part. First of all, in here, we can use the first method. And in this part, for our first method, which is the comparison of coefficients or coefficient comparison, then inside this part, so first of all, I'm going to let, but which part? So here it is only an x at first, x, but all the way up to here, the 5th derivative. From the 5th derivative, you want to get x, then for that part, will need to be something about power of 6. Then this a, when you sum in this part, all those in front here will need to be able to cancel out. So all of those need to be able to cancel out. So the last part remaining will just be here. So that both sides would be equal and then it will be right. So first of all, we'll find the first derivative. You can write it as that, or you can also write it as this way. So first of all, this is the first derivative. So you can differentiate this part. So you get 6a x to the power of 5, then e to the power of 4x. Or you can also differentiate this part at the back. So basically you're using the product rule. So then this part will be 4. 4a x to the power of 6. Then here is e to the power of 4x. So this part we are using the product rule. Then for the next part will be for our second derivative. In our second derivative, here, x to the power of 5, so you get an x to the power of 4. Then after that, so 6, then you have the times 5. So then you get 30. Then in the next part, we can differentiate this part, so you get 24 of this. Or this part, you differentiate, you get x to the power of 5. So it's also 24 and they're actually all the same. So that will mean here you can have 48 a x to the power of 5, then e times x e to the power of 4x. Then for the next part, still here, but beware, when you differentiate, this will come down, so you have another 16. Then for the next part is the third derivative, So just gradually increases. First part will go down to a cube. So at this part, it's 120. Well, if you need this for faster calculations, well, this part you can just use that calculator so that it will be as fast. Just that you have to make sure of about which of them you'll need to multiply. So that's for the part about x to the power of 4. The next will be for x to the power of 5. So you have to include both of these parts. So when you include both of these parts, here it is 336. Wait, spark. We just accidentally pressed wrong one thing. It's supposed to be 288, like this. Then of course, next part would be for x to the power of 6. Now x to the power of 6 will just be 4 comes down, so it is 64. Then for the next part, it is the fourth derivative. So for the fourth derivative, here's 360. And here you have an extra, you have square. Then after that, you'll get for cube. So for cube at this part, first of all, is 4. Then in the next part, it is about this 360, but this x to the power of 4, it differentiates, it becomes x to the power of 3. So this part is 1920. Then next, at this part, you have here. So of course it is x to the power of 4. Then here is e to the power of 4x. Then of course in front you have the a. So at first this part we need 4. Then after that it is 288. Then here you times the 5. So you get 2880. This part. So let me just write that more clearer. Okay, then for the next part you'll get will be for x to the power of 5. So for x to the power of 5, here of course 4. So at this part what you will get will be 1536. Then of course for this part at the back you times another 4, you get 128. Is only for times 2, so if you're just doing it step by step, first of all it's 128, after you times another 2, you get 256. Then last but not least is for our fifth derivative. So in this fifth derivative, you'll get another part. And for this part, it will just be times the extra 2, which is 720. But if you have realized that here at first times 6, then times 5, times 4, times 3, times 2, well 1, you can just leave it there because anything that's times 1 is still the same. So basically this is 6 factorial. You can write it in this form if you actually immediately realize that it is 1 times 2 and so on. A, then at this part x, and here you have e to the power of 4x. Then the next part will be for our square. So in this part for our square, beware, it is both of these parts. So you get 7200 x squared. Okay. Then after that, will be for these two parts, which is about x cubed. So for x cubed, you get 19200. Then beware, you still have this a x cubed e to the power of 4x. The next will be for x to the power of 4. So you get 2. Excuse me. So at this part, what you have will still be 19200. Then you have a x to the power of 4, e to the power of 4x. Then of course, to the power of 5. So 1536. Then here will be about 4, then 6. So here will be 7680. Then a x to the power of 5, e to the power of 4x. Then at last this part, 256 times 4 is just 1024. So it is, this whole part will be just like this. So let's have them all inside. Of course, this part will be just alone. So you can write it. Just alone like this. Then we calculate for the other part. So here, 7200, 7200. Then you have to minus 20 times 360. 20 times 360, so that will be a 0, so you don't need to write about that. Then after that is 19200. Then after you minus 20 times this part, that is a 1920. Then after you subtract these parts times together, which is a 120 and 160. Just a moment here. Okay, and you'll still get a 0. Then next, you move on to this part. So beware, it might get a little bit of confusing, but you just have to beware of its power. So this x to the power of 4, then you get 19200. Then you subtract. Next is here. So it is 20 times 2880. Then after that, here it is 360. So you have to plus 360 times 160. Then after that will be for this power of 30. So minus 640 times 30. And you still get 0. Then next is x to the power of 5. So here, the next is this part, 1536. Then you times 20. Then after that, here 288. So you get 288 times 160. The next is for this part, and you will get minus 640 times 48. Then after you just add on, so 6 times 1280. Okay, and it's still 0. Then next for this part will be the last part with x to the power of 6. So first is 1024. Okay, 1024. Then you subtract 256 times 20. Then you add 160 times 64. Okay, and this process just goes on. And at last, you'll still get a 0 for that part. Now, all the others are zeros. That means you only have this part. And this is equal to x times e to the power of 4x. So, at this part, that means a will be 1 over 6 factorial. Then let's have it inside. So, at this part, this particular solution here, it will be 1 over 6 factorial x to the power of 6 e to the power of 4x. So that's for this part. Next up, we are using our operators method. So that will be for method 2. Method 2, our operators. So we first write this whole part into the form of our operators. So you get d to the power of 5, y. So all these parts first. So it'll be like this. You have all these parts. Then you can just take out the y from this front part. Like you're just imagining that you can actually take that out. Then after that, you put the y behind, and you have to be where it's always behind. And if you want to know why it's actually always behind, well, there are videos that are explaining why it always has to be behind. So at this part, you want to try to factorize this part. You want to try to factorize this part, or you can just call this the polynomial of operators. You want to factorize it. And you think about it. Here, d. Ending 1024. 1024, it is 2 to the power of 10. So what if it is just d, 2 to the power of 10, you can just separate them into 2 to the power of 2, which will get 4. Then to the power of 5, and here is a minus as here it is alternative. So actually this is it. But if you just want to be very, very sure, yes, you can go ahead, then expand it again, then try to find out whether is it the actual part. So this polynomial part, you're just factorizing it into this binomial form. Okay, so this is actually also a binomial part. But at this part, we cannot use our original methods with partial fractions. But what we can use is, first of all, since we have 5 at first, we can put 4 outside first. Then we work with one of these. We work with one part first. So at this part, what you have at this part will be, so outside, it will be e to the power of 4x. Then here inside, well, they will just simplify. But then you have half x squared. Then, of course, outside here, e to the power of 4x. Of course, you need to have that. Then after that, take one more part. Wait. After that, you work with the remaining. So at this part, it is already squared. Then next, it will become a cube. So when it becomes a cube, here you can just write it as 3 factorial, or you can write it as 6. So here's the cube. But outside, there will still be this e to the power of 4x. So if you have realized this kind of pattern, then you can just write on and on. Then you can just straight away write square. When it is a square, it just changes. This you can write it as 2 factorial, since times 1 is still the same. So you just straight away become 4 factorial as this part times an extra 4. After that, here is x to the power of 4, then e to the power of 4x. Then in the next part, 5 factorial, x to the power of 5. Then 6 factorial, x to the power of 6. Like this. Then this part is what you have. And plus, you can write this p if you want. So these two parts, they're actually the same. But if you have it the same, that means this is correct. But what type is this? For this type, it is from this part. You actually realize that they are repeating. So you have those kind of things that are repeated roots. Well, we'll call this multiplicity. So like at this part, multiplicity of 5. At this part, since here is 5 times, okay? So whether which power, well, in general, we just say it as multiplicity of k. So it depends. So in this lesson, I hope all of you are clear so far. So we'll end this lesson here. And if you like our videos, don't forget to subscribe to our channel. See you in the next lesson. Thank you for your watching.